All right, Honors Algebra 2 and Algebra 2. Here is your first game plan video for 4-1-4-3 game plan. Fall in the 2019 and beyond. This is fall 2020. Okay, so I'm going to give you the first half of it today. First off, in class, we learned of standard form of a quadratic, ax squared plus bx plus c, the squared term, middle term with just x, and then the constant. Okay, so on b here, what we're going to do is we're going to distribute. The 3x squared terms would cancel. You're left with negative 6x plus 6. That is linear. It's a straight line, slope of negative 6. Then on the first b here, first outer inner last, we FOIL it up, get 3x squared minus 16x plus 5. The x squared term, the 3x squared. If you have it to the second power, that means it is quadratic. So there's an example of something linear, something quadratic. That's how you do the whole page. Okay? Next page here. This is page 2. Identify the vertex. That's the vertex, either the bottom or the top of your parabola when it goes from decreasing to increasing or vice versa. So the vertex is a point, 1, negative 1. The axis of symmetry is a dotted imaginary line that cuts it in half. That dotted imaginary line is x equals 1. It's always the x-coordinate of the vertex. The range is all the possible y values. Negative 1 is the smallest y value. Then y is going to get bigger and bigger and bigger until it approaches negative or positive infinity. So y greater than or equal to negative 1. Algebra 2, that's a fine way to answer it this year. Okay, this next page, page 3, probably one we're going to do later. So graphing a parabola when the vertex is at x is 0. So how we would have started this in class is I would have told you plug negative 2, negative 1, 0, 1, and 2 in for x. Tell me what you get for y. You get the following. We would make a graph like that. All right, sort of makes a U. So graphing, again, if there's no middle term, then the vertex is 0 something, 0, whatever the constant is. So 0, negative 4. Just like when I did the absolute value, I go 1 to the left, 1 to the right, 2 to the left, 2 to the right. Okay, I do still have symmetry. Okay, so that is my vertex. When I plug 1 in for x, I get 2 minus 4. It's a negative 2, so that's why it's a negative 2 there. I don't know why I plugged the negative ones in. Then when I plug 2 in for x, I get 2 squared, which is 4. Double at 8. 8 minus 4 is 4, so that is also a 4 when I go 2 to the left. And then I just graph it. It's a stretch of your U. Not a great one there. 2 is a little interesting because it has a negative 1/2. Again, the vertex is 0. There's no middle term. The vertex is 0. There's the y-coordinate in the vertex 3. I'm not going to go 1 left, 1 to the right, because when I square 1, I'm left with 1. 1 times a half, or negative 1/2, is going to give me a decimal. So I go 2 to the left, 2 to the right, 4 to the left, 4 to the right here. So when I plug 2 in for x, I square it. I get 4 multiplied by negative 1/2. That's negative 2. Add 3 to it, I get 1. So I get 1 there. Again, this is the vertex. I have symmetry. And when I plug 4 in, I square it, I get 16. 16 times a negative 1/2 is negative 8. Negative 8 plus 3 is a negative 5. So negative 5 there. This time when I graph, I made a boo-boo. This is the correct point. Negative 2, 1 is here, not there. Okay, it's an upside down U. I call it the igloo. It has a maximum. Okay, then we're graphing parabolas in the form ax squared plus bx plus c. This time there is a middle term, and I find the middle term by finding the vertex. The vertex is not 0 something. The vertex is found by negative b over 2a. That's the x-coordinate of the vertex. And then whatever the x-coordinate of the vertex is, I plug that in for y. So I got to do negative b over 2a. And you're talking about what? What comes from this? Ax squared plus bx plus c. Standard form of a quadratic. So b is the middle term. A is what's attached to x squared. So the opposite of b, that's negative b, which would be the opposite of 4, divided by 2 times a. A is a negative 2. Negative 4 over negative 4 is 1, so the vertex is 1 comma something. I plug 1 in for x, because that's the x-coordinate of my vertex. I plug 1 in for x here and here. All right, and then I evaluate it. I get 3. 1, 3 is my vertex. Now I still go 1 to the left, 1 to the right, 2 to the left, 2 to the right on my vertex. I plug 2 in for x. I plug 2 in for x, and I get 1 for y. I plug 3 in for x. I get -5 for y. So again, because of symmetry, 0, 1, -1, -5. It makes the igloo again because I had a -x squared. When you have a -x squared, it makes an igloo. It has a max. When you have a positive x squared, it makes the u. It has a minimum. And that is important to know for literally this next page. It says, without graphing, find the vertex of the given functions. State whether the vertex is a min or a max. So again, if you have a -x squared, just like the last graph, it has to make the igloo, and the igloo has a maximum value. So that is very easy to answer. I do -b over 2a. -b over 2a. The opposite of 2 is a -2, divided by 2 times -1. The x-coordinate of my vertex is 1, so to find the y-coordinate, I simply plug 1 in for x to get 4. My vertex is 1, 4, and that vertex is a maximum. Points. 4 is my maximum y value. Do it again here on 2. So this is a positive 2x squared, which means my graph is the u. A u has a minimum. -b over 2a, so the opposite of 4 over 2 times 2, that's a, gives me a -1. I plug -1 in for x, plug -1 in there and there. Okay. And I get 5. -1, -5 is my vertex. On number 5 here, the vertex of the following function's graph is given. Find C. Well, if I give you a point that it goes through, so I know that x is 3, when y is a -4, so plug -4 in for y, plug 3 in for x, and solve for C. Really not much going on there. It should be difficult. What is the y-intercept, folks? The y-intercept is when x is 0, so plug 0 in for x. Simple as that. Plug 0 in right there. 1 squared minus 2 is a -1. So you can say y equals 1, or write the y-intercept, which is a point. It's when x is 0 and y is -1, 0, -1. All right, on the next page, this is vertex form. We don't do a lot of graphing. This one of the last ones. So in vertex form, this is it, okay, right here, example 1 and 2 are examples of vertex form. What I do is I set what's inside that parentheses equal to 0, kind of like when we had that absolute value function. And I get x equals -1, and then the y-coordinate of the vertex is looking at you right there. The vertex is -1, -4. I go 1 to the left, 1 to the right, 2 to the left, 2 to the right of the vertex. So I'm going to plug 0 in for x. When I plug 0 in for x, it's right here. I get 2 times 1 squared minus 4. That's a -2. So that's a -2 right there. All right, then I'm going to plug 1 in for x. Plug 1 in for x right there. That's 2. 2 squared is 4. Double it, you get 8. 8 minus 4 is 4. Plot those points, you get a u. All right, so probably a page we would have done in class. Just write each function in standard form, ax squared plus bx plus c. Just distribute, combine like terms. All right. On D, we're going to FOIL, right? 2 minus 5x twice. Again, would have showed some of you guys the trick, how to do that quickly. Then add 12, and that is standard form. Next page, let's look at the second one here, the graph. We're almost done with the graph. And this is vertex form. You set x plus 3 equal to 0. You get x equals -3. Y-coordinate of your vertex is a -4. And that's that answer, -3, -4. It is a minimum value, okay? It's a positive x squared, so it's a minimum value. The axis of symmetry is always the x-coordinate of the vertex. What will cut this graph in half? X equals -3. The minimum value is -4. Then graph it. Go 1 to the left, 1 to the right, 2 to the left, 2 to the right. You're dealing with negatives. Okay, and off to the side, I plugged f of -2 means plug -2 in for x. I got -3. Plug -1 in for x. I got 0. -3, 0. And then we made that nice u there. All right, let's keep going here. 1 through 4 and 4 through 7 simplify, so you're just foiling on number 2, first, outer, inner, last, combine like terms. You're just doing some distribution on number 3. All right, all from Algebra 1 on 8. You are foiling 1 minus 3x, 1 minus 3x plus 5. X squared's first. Again, the x squareds cancel. Number 3. Number 5 here. Again, pause this whenever you need to. Find the vertex and say whether it's a min or a max. Well, first off, that is a positive 4x squared. I forgot to, so that makes a u, and a u has a minimum. So that's the first answer. Negative b over 2a, always. So the opposite of a negative 16 is a positive 16. 2 times a would be 8. 16 over 8 is 2. Plug 2 in for x. There and there. I get negative 9. The vertex is 2, negative 9. Oh, and on 10, identify the vertex and the y-intercept. I forgot to do the y-inter. No. No, I got the y-intercept. It's right there. Y equals 5 or 0, comma 5. Okay, the vertex, again, set this equal to 0, x minus 1. If you set it equal to 0, you get x equals 1. This is in vertex form. 1, 3 is my vertex. Then I'm going to plug 0 in for x. 0 minus 1 is a negative 1. Square it, you get 1. Double it, plus 3, you get 5. Just a few more pages here. Number 2, what is the correct quadratic function in factored form? First off, your zeros are x equals negative 3 and x equals 1. Move this over to give you x plus 3 equals 0. Move this over to give you x minus 1 equals 0. X minus 1 times x plus 3. If you had those set equal to 0, you would do the cover-up method to get x equals 1, cover-up method to get x plus 3 equals 0, or x equals negative 3. So it is D. All right, number 3 is pretty easy here. State the vertex. Well, this is in vertex form, so set this equal to 0. You get x equals 1, and then the y-coordinate of the vertex, negative 5, and it makes the u, so it opens up. The graph is going up. Here, you set x, x plus 3 equal to 0. You get x as a negative 3. Y-coordinate of the vertex is 12. Makes an igloo, so it opens down. Negative x squared makes the igloo opens down. All right, we're getting close here to the end of video number 1. Given the graph of the quadratic function, state the zeros and give the vertex. Crosses the x-axis there and there. The zeros, the roots, the x-intercepts, the solutions all mean the same thing. The zeros are x equals negative 4 and x equals 0. That is clearly the vertex there. The vertex is negative 2, positive 4. All right. Foiling review, and that's all it is here. This is page 17. First, outer, inner, last. Okay, this is just get a few answers here. Be careful on 15. Again, first, outer, inner, last. 7, first, outer, inner, last. And then 17. And this is the end of this video. All right, this is Yak Math Videos signing out.